We end this test review with a couple word problems. So let's read this. Michaela left the movie theater 1 hour before Ted. They traveled in opposite directions. Ted traveled at 20 miles per hour for 2 hours. After this time, they were 220 miles apart. What was Michaela's speed? Well, this is clearly a problem that relates to distances. And we know that with distances, we know that rate times time equals distance. So we're going to remember that rate times time equals distance. Now, what we want to do when we work with these questions, there's usually some type of relationship between the distances. The distances either add together, so distance 1 plus distance 2, to equal some total distance. The two distances might be equal to each other. And the other option is sometimes like you have your distance 1 plus or minus some other number will give you the second distance. So we want to look at this and relate the distances. So it says they left the movie theater 1 hour before Ted. They traveled in opposite directions. Well, that's important. They traveled in opposite directions. Ted traveled for 20 miles per hour for 2 hours. Wow, that's very slow. After this time, they were 220 miles apart. So here's the movie theater. They traveled in opposite directions. So which relationship is it? Is it relationship A, B, or C? Well, after 2 hours of Ted driving, they were 220 miles apart. Well, this seems like it will be one person's distance plus the other person's distance equals the whole thing, and that's what it is going to be. So we know that Michaela's distance plus Ted's distance, so we're going to do D sub T, is equal to, if we add those together, it will be the 220 miles apart. Well, we do know that distance equals rate times time, so this is going to be Michaela's rate times Michaela's time plus Ted's rate times Ted's time will equal 220. Let's see what we know here. Michaela left 1 hour before Ted, but then it tells us later Ted traveled for 2 hours. So we know two things here. The really obvious one is Ted traveled for 2 hours. So Ted's time is 2. But it says Michaela left the movie theater 1 hour before Ted. So what's her time going to be? Well, she left an hour before. So she left, there was an hour. Ted left, there was 2 more hours. So Michaela was actually traveling for 3 hours. Michaela left the movie theater 1 hour before Ted. They traveled in opposite directions. Ted traveled at 20 miles an hour for 2 hours. He tells us what he actually traveled, 20 miles an hour. So this is going to be 20 times 2. And then what is Michaela's speed? That's actually what we're trying to find. So let's go ahead and put an X there. So we're trying to find X, and we know we have 220 here. Well, this seems like a pretty simple algebra problem. This is X times 3, which we normally write as 3X, plus 20 times 2 is 40, equals 220. We can go ahead and subtract 40 from both sides. 3X equals 180. Dividing both sides by 3, we get X equals 60. Well, X stood for Michaela's rate or Michaela's speed, so 60 miles per hour, that is what we were trying to find. So there's our first one. In this case, it wasn't too difficult. We realized that the distances fit this situation. We knew a lot of our things, our rates and times. We only didn't know Michaela's rate, and that's what we found. We come to our final question here. It says Arjun drove to his friend's house and back. The trip took 5 hours. The trip there took 5 hours, and the trip back took 2 hours. He averaged 42 miles per hour faster on the return trip than on the outbound trip. What was his average speed for the outbound trip? So we have outbound, so that's going. He's going there. And then there's the coming back. So we had mentioned these 3 different situations before. You can either have the 2 distances add up to equal some total distance. Second option was maybe the distances are actually the same. And the third option, which is a little bit more rare, you have one distance plus some amount will equal the second distance. Well, what do we have here? It says Arjun drove to his friend's house and back. Well, he drove there and back. He's going to someone's house and then he's going back. We're going to assume he took the same route. And so this means the distances would be the same. And so we're going to say the distance going. Let's just use a G. Oops. Distance going is going to be equal to the distance returning. So just so we remember what G and R stand for. All right. Well, we know that distance is equal rate times time. So this is going to be like our rate going times the time going is going to be the rate returning times the time returning. So we needed to figure out that the distances were the same. So usually if someone's going there and then returning, the distances will be the same. The trip there took 5 hours. Well, that's going. So we know that this trip took 5 hours. And the trip back took only 2 hours. So the return trip took 2 hours. He averaged 42 miles per hour faster on the return trip. Now, what I normally do is I let a variable represent one of the rates, and then relate it back to that for the second rate. So let's just say the trip going, his rate was X. Rate, so let X equal the rate going. Well, what's his rate returning going to be then? And don't just say Y. We want to look at it here. He averaged 42 miles per hour faster on the return trip. So he was driving faster on the return trip. So what we do is take our rate going and we add 42 to it. And so his rate returning was X plus 42. And we have a pretty simple equation to solve. This is 5X equals, we'll go ahead and distribute 2X plus 84. And to solve, we can subtract 2X from both sides. 3X equals 84. Dividing both sides by 3. X equals, what is that? That's can't think right now. 2, 6, 28. So X equals 28. That was the going rate. That was going or the outbound, so 28 miles an hour. What did we want to find here? What was his average speed on the outbound trip? 28. So that's what we were trying to find. Maybe the other time, maybe it would say what's his return rate, and we would have to do 28 plus 42. But in this case, it asked for the outbound trip. Just for extra, we'll find the returning rate. So the R sub R, returning rate, would be the 28 plus the 42, which would be 60 miles per hour. But we didn't need to find that. That's just extra. You are